And please welcome Rick Harvey.
Hello everyone, thank you for staying around right till the end. I know the football's on at the moment as well. It's 0-0 at half time, so everything to play for. Yeah, I know that might be a spoiler in case you were saving it. So today I have no slides for you. This is something I'd promised myself I'd do a few months back. More presentations with no slides, just all demo. Now it's going to prove to be a very brave thing or a very stupid thing, depending on how this goes. There's lots of stupid things happening in my country now, so this may be one of them. So let's get going. Now, what I'm going to do today, I'm going to do an example of AWS Fargate. Fargate is a technology that lets you run containers without managing infrastructure. We have something as well called ECS, Elastic Container Service, and ECS manages a control plane for you. You bring your own workers. Fargate is the next step on from this, and you don't manage anything. You just give us a container and we'll run it for you. So I'm going to try and show you today how simple it is to use that and highlight some of the new features that we launched end of last year, beginning of this year with Service Discovery. All the code I have is available at this URL here, gitlab.com, Rick Harvey, Builders Lab, Practical Fargate. So please do pull the code down, have a play with this after the session at home, submit some merge requests, correct my typos, which there'll probably be lots of in this. And see what you can do. But everything you see that I'm going to do here today, you can take home and do after this session. So that's the real takeaway. So let's get going. Let's go to my browser. So this is a GitLab repository. This is the Builders Lab. What I'm going to build today on stage is I'm going to create a Fargate cluster, which sounds a bit crazy because I've just told you don't run any infrastructure. But all we have to do is tell Amazon, give me a concept of a cluster where your containers will live. And part of the reason for doing this is that you can have logical separation of boundaries of applications. So you can create a dev cluster and a test cluster in the same account, and putting containers into one cluster will never interfere with another. So that's one of the reasons why we still call it a cluster. I've included some links in here, including links to the pricing of Fargate. Another advantage of Fargate is you only pay for the container resource that you consume. So if you're using half a CPU and 512 meg of RAM, that's exactly what you pay for. You don't pay for the underlying EC2 instance. You just pay for that container in there. So if you go to this link, it will take you to a calculator and you can work out how much it's going to cost to run your application. All the infrastructure behind this as well, it's worth saying, is highly available. It's scaled for you in the background. You don't have to do anything. So as your application, you may have enabled auto scale on it. As it grows bigger, we'll scale the infrastructure seamlessly behind there. We'll also manage patch that infrastructure behind. You won't see any of this going on. There's no heavy lifting on your part. You can concentrate totally on your application and your container and keep your innovation there. That's the idea of Fargate. So what are we going to build today? We're going to build a really simple little application. It's a Node.js Socket.io web service. It's a chat service. You'll actually be able to log on to this at the end of the demo and put messages on the screen. Please keep it clean. It's on video. And it's backed by a Redis container. Now, in reality, if I was doing this in production, I wouldn't use a Redis container. I'd use Elasticache, which is one of our other services. But the reason for using a container in this case is I wanted to highlight service discovery that is now part of ECS and Fargate. And it's also available on EKS and Kubernetes if you use the open source plugin to connect that up. It's basically backed by Route 53, which is our DNS service, and our AWS Service Discovery Catalog. So it links the two together very easy. But I just want to show you how easy it is to do this. So this is what we're going to build. We're going to have an application load balancer on the front, which is what you can connect to. We're going to have 3 containers running for our chat front end, and we're going to have a Redis container that passes the messages between those front ends in the back. This is what we're going to build in theory. Now, I'm not going to bore you with the rest of this page and scroll through it as we go along. This is for you to use after. I'm going to dive straight into the console. And I've already created my VPC. I've included a CloudFormation, which is our orchestration tool. I've included CloudFormation scripts for each step of this as we go along. The dev VPC, this is my virtual private cloud, my network. It consists of 6 subnets. I've got 3 public, 3 private subnets. I've got network NAT boxes in front of there, automatically created, and I'm building a public and a private load balancer. In this demo, we're only going to use the public one because I want you to all log in and have a play with it. Now, I created this beforehand just for the interest of speed of this demo. It takes a couple of minutes to spin up a VPC, and especially with all the parts I've been adding. But everything else we're going to build by hand. This is my VPC. Here's my 6 subnets. We don't need any more of that. Now, I'm going to drop you to the ECS console to start with, just to prove I'm not cheating on this part and there are no clusters created. So the first thing we're going to do in our demo is actually we're going to spin up a cluster here, and we're going to do it all from template. Now, all these steps are in the README documentation, and here we go, Fargate cluster. Let's open this up. Now, the only things I've got to do on this template is change the name, because I haven't created a VPC called production. I've created one called dev. The more astute of you will have noticed that. So there's a little few changes that we'll do to this script on the way through. But this is set up for all intents and purposes, so you can name it whatever you want. My stack name, first of all, I'm going to call this a dev Fargate cluster, and I'll show you what this does in a minute. My environment is dev. I'm not going to set anything special in here. If you're going to do this in production as well, I'd highly recommend looking at how IAM roles interact with Fargate and how you can enhance the security of your cluster. By default, we automatically add some housekeeping IAM policies into your account, and that's just so we can reach into those instances, update them, make them join a cluster, and provision the infrastructure for you. You don't have to worry about any of this, however. So I'm going to hit create on this, and this is going to take hopefully a minute to create, but who knows with the demo gods with us. What's happening in the background now? I'm instructing the ECS, this is the management control plane, it's identical for Fargate. I'm instructing ECS to create me a cluster boundary. So when I send commands to this cluster, it knows what to do. The real magic that's happening underneath is with the Fargate extension to ECS. What's going to happen when I send a container its way in a little bit by creating a task and a service is that we're magically going to spin up some infrastructure underneath for you. We're going to create some infrastructure that you will never see in EC2. This will spin up and your container will get placed. We'll also do the scaling of that instance behind for you, and the maintenance, so security patching, all that's handled for you. So I'm going to keep hitting refresh on that a few times just to pray. But we should start seeing some things happening in Fargate here right now. Now it's worth just talking about this screen for a minute, because right down at the bottom it mentions EC2 hosts. Well, I've already told you we're not going to have any. But this is because Fargate and ECS use the same management control plane, you can actually have a hybrid cluster. And a hybrid cluster is incredibly useful. So I've told you you don't have any access to Fargate underlying infrastructure because we do all the updates for you. So that means if you want to debug a container, if you want to SSH onto it and use Docker exec to try and drop into that container to do things on the fly changes, which you really shouldn't do, you can't, because you can't get in the underlying infrastructure. But if you really, really, really need to do that for some reason that you haven't got full login set up, what you can do with a one-word change in your task and service definition, and that's swapping the word Fargate for EC2, you can move from Fargate to EC2 instances. So you can move your task and move your workload back and forth within the same cluster. So you can have a set of EC2 instances up and running. You may have done something special to that EC2 instance. You may have attached network file storage on EFS, NFS or Gluster on there. You may have done some kernel tweaks, all things you can't do in Fargate. So this is why a hybrid one comes in useful, because sometimes you need to do things special. But if you don't need to do it, go for Fargate. There's less management on your half. Let's have a quick look back now at CloudFormation. Hey, create complete. I like it when things go green. So I have a cluster now. You've seen it here already. We've got a big long name on it, and that's just because there's a unique ID added to the end by CloudFormation. But I want to quickly show you that in our EC2 console in that same region, I have no infrastructure running. I've got nothing to manage. My time as an operations person has just got a lot easier. So we've got no infrastructure. So the next thing we're going to do, we're actually going to create a container. We're going to create the Redis container. And this CloudFormation script is going to go part way to what you'd normally do. It's going to create something called a task. Now, if anybody's used to Kubernetes, what is a task? A task is a pod. It's a definition of your container or containers. Up to 10 containers max. You can define them, and if they're closely related, they all get put together on the same host. Why the same host? Well, Fargate uses VPC networking. And what actually happens here is that task gets given its own network interface into your AWS infrastructure. And this is great because it means that that task isn't competing for network resources with any other container running on that host system. So you get very fast access in. It's also in your VPC. Being in your VPC, if you don't want to make it public and you've got a direct connect in there or you've got a VPN in from your office, that means you can have access to that resource on a normal IP address without having to do any fancy routing around your cluster. So the next thing to do, let's create this Redis container. Now this is all quite self-explanatory as we go through here. So what we're going to do is create a dev Redis master. You can see I've practiced this a few times, can't you? I've got the names already in my autofill. And there's just some container and CPU memory settings here. I only want one, that's the desired count. I only want one version of this Redis container. I'm not going to do any clustering with this one. So I want one copy of my task. And the image URL is Docker format. So this is coming from Docker Hub. I'm going to pull down the latest Redis image from Docker Hub here. And we're going to hit next and next. And this one should be quite quick to create because it's doing very, very little. So as we go through this, complete. Now, I'll show you what this has just done. I mentioned task definitions. Kubernetes language, this is a pod. So in here, I now have this section here called Redis Master. And it'll actually be Redis Master 3 because I've practiced this talk twice by going through the whole thing. And this is a definition of our service. And in here, if we flick to the JSON, you'll be able to see things there like we've got log groups set up, we've got port mappings of 6379. You may have spotted that on the other screen. You'll find that we're going to call it Redis Master, and if we scroll down a little bit, somewhere in here you should be able to see the container name. But there's a lot of settings in here on top. Network mode, AWS VPC, that's the thing I just mentioned to you, and we require Fargate for it. Now it's great having a task definition, but a task doesn't actually run on its own. So we create a service. The job of the service is to place a task in our cluster and to monitor it for health, to make sure it's always running, and to do things like connect it up to load balancers and other services within AWS. That's what a service does. It places for us. So if I click on this, I can now say create service. And I always wait a few seconds here because I once overshot and clicked Fargate and it hadn't refreshed the console on it. I got big red error messages, and like I say, I like green, not red. So let's go through here and see what we can do. So our service is going to use the family Redis Master version 3 of that task definition. And I've only got one cluster, so this is automatically pre-populated. If you've got more than one cluster, just nip into the cluster section and find the cluster name and make sure you select the right one on that. Service name. I'm going to get highly creative and call it Redis Master again. I only want one version of this task created, and I'm going to hit next. Now, let's scroll to the top. We're going to be asked a few things about where to place this, in particular what VPC. And that's because none of this can be pre-populated, because our cluster is just a logical boundary. It can go anywhere at the moment. So what I'm going to do, I know these settings off by heart now, but it's all listed in the README, so you should be able to find them. I need to select the 3 private subnets, which are the 10.0.3.0/24, 4.0 and 5.0. And there's another little tweak I need to do, and this is normally where I forget the actual port for Redis. And I've got a weird screen format here, so I'm hoping that's custom TCP, and it's 6379. Yeah, at least people are recognizing it here in this audience. It's quite nice. So I'm going to be lazy, and I'm going to leave it open to anywhere, which is not best practice, but we're doing a demo. I don't want to complicate this. We're already pushing the boundaries of whether this demo will work. The thing is, I'm running this in a private subnet, so there's no public routing from the internet, so there's a little less danger than normal, but we'll just hit save on that. And the last thing I want to do is disable a public IP. I just want a private IP address for this. Now, that's great, but if I've got a private IP address for my Redis container, do I have to pass that as a variable to my front end container? Well, I would. What if that container gets killed and gets spun up somewhere else and gets a new IP assigned to it? Well, I've got to restart all my container. So really, I want to use DNS, and I want to be able to go to a Redis DNS endpoint, and I want that to be updated automatically every time the container restarts. And that's what we started doing with this service discovery option. Now I'm going to let service discovery go and create me a whole load of new stuff. It's going to create a new zone in my Route 53. Route 53 is our DNS offering from AWS. At the moment, you can see I've got 2 hosted zones. And in there, I've got a public one called digillution.io. And I've got a production variation of that, which is just some experimenting that I was playing with the other night. What this is going to do is going to create me a namespace called local. So I'm going to get a new zone in my DNS called .local. And what's going to happen then is that when this container comes up, it's going to register itself automatically with DNS and the service discovery catalog, and we're going to have redis-master.local as a DNS endpoint. That's in theory. That should happen. So I'm going to leave this all as defaults because I've cleaned up and it should all work. Now, one thing I'd say about this console that annoys me immensely, and please feed it back to our teams because I want them to change it. This DNS record for service discovery, the default TTL is 60 seconds. Now, we're talking about replacing a container if it goes down with a new one. If I've got a TTL of 60 seconds, I might have to wait 60 seconds before my application can find where the new Redis container is. That's not good. So drop this down to something significantly lower. For this demo, I'm just going to put 3 seconds in, but consider even lower if you want very, very fast failover. So next step here. This is just all defaults again, so we'll go through this and hit create service. Fingers crossed here. Oh, we've got a bit of green. We want lots of green going here. So it's creating the DNS that normally catches me out on this. And it's normally because I've forgotten to clear up my last demo. But this is good. We've got lots of green. Yes. Thank you, demo gods. Now, one thing I don't go into in this actual demonstration is connecting this to a CI/CD pipeline. But if you have a look on that GitLab URL that was at the beginning, I'll put it up again at the end. You'll find another one of my builders labs. and it talks about ECS, and it talks about setting up a CI/CD pipeline. So when you commit your container to Git, it'll rebuild it automatically, push it, and replace it within your cluster. You can do exactly the same thing with Fargate that you can with ECS, so you can reuse that and have a go with that if you'd like. I'm now going to hit View Service just to have a quick look here. Let's drop back to the cluster level. So now you can see I've got one service defined in Fargate and not on EC2. I've got a pending task, and hopefully that'll move to a running task in a moment. What's happening in the background now is that Amazon is all of a sudden spinning up an EC2 host for you that you'll never see. And in that EC2 host, it's going to place your container. That container will get an elastic network interface connected to it for your task, and the image will get pulled down from Docker Hub. So there's quite a lot of things happening in the background now, which is why I'm talking quite a lot to wait for it all to happen. Right, we've got a running task. So we have a Redis container running. And if we drop back to my Route 53 now and have a refresh on here, with any luck, I've got a local zone now. And within my local zone, I've got an entry for redis-master.local. And I've got a 10.0.4.209 IP address. That's one of my private subnets. So that's good. It's looking good at the moment. So the final thing we're going to do before we can all play with this is I'm going to create the final stack. Now this stack I have to do less manual steps on. I only did the create service by hand that time because I wanted to show you the new service discovery feature. Normally you'd put all this into your CloudFormation script. Why put it in a CloudFormation script? Or Terraform, I'm happy for either to be used. Well, it means that if you want to have separate clusters, you want to have a dev, a test, a stage, and a production, you can move identical configurations between clusters by changing one variable. And that's an incredibly powerful thing. So where you can automate, automate. Write your infrastructure as code and do it that way. Right, final template. Now, in my demo here, I go one step further. I hope I've hashed it out, unhashed it anyway. So I'm actually going to create a public DNS endpoint for you guys to all be able to log in and access this as well. That's a lot easier than using an ALB address. When you do this in your own time, you'll have to go and find your load balancer DNS entry and then stick that in your browser. I've tried to make that a little bit easier for you, and I hope I've re-enabled it. So let's give it a go. So this is our chat application. Here's my constraint again around my container. My container actually runs on port 3000. This is important because the service is going to tell the load balancer which port to connect into my cluster on. And I want 3 of these to run. I want 3 copies of my container to be running at all times. Yet again, the container is on Docker Hub. I did used to do this with using our ECR, which is our private registry. But to make this accessible to you all here, I've put it into Docker Hub so you can pull that. So it'll work with either or. One thing to note is that at the moment, Fargate works with all public images, and it works with private images from ECR. We are working on adding support for other private repositories as we speak. So that should be coming relatively soon. So I'm going to create, I'm also going to tell my container to connect to my Redis container here. This is our service discovery address, redis-master.local. So I don't have to restart the container if Redis restarts. I'm going to hit next, next, and create. That was rather cavalier, wasn't it? And we're going to sit here and twiddle our thumbs a few minutes while this all starts. We should start seeing things happening. I love it when it does that. Here we go. No clusters found. It's always a heart attack moment. Here we've got 2 services defined now, but I've only still got 1 running container. What will start to happen here as the task definition is created through CloudFormation is that we'll see 3 pending tasks. That's the 3 copies of my container. And they should all move into running tasks. So we should have 2 services and 4 running containers at the end. Now, one of these containers starting will be a little bit quicker because it's going to use the existing infrastructure that Fargate's already deployed for me. The other 2 will be a little bit slower because it's bringing more infrastructure into my cluster automatically for me and spreading it. Because I've told this to spread my containers in availability zones for high availability. Because my chat app is so important, I need high availability for this. Right, we've got 4 running tasks. And if I come over here and wait, this will probably be the DNS registration that's going on now. What I'm going to do is in my public DNS zone, and I'll make this a little bit bigger in a moment for you. That's promising. Seems to be there already. Right, create complete. I've created a URL called fargate-chat.digillution.io, and when I hit this, and can you see that? Is that big enough for you to read there? Cool. When I hit this, I'm going to ask what my nickname is. I'm going to go in, and I've got a very simple chat app up. Now, if any of you have got your phones handy, and you can go to that same URL, hey, people are joining. You can start putting offensive things on the screen now and and talk to me about whatever you want to talk about. So I've got a chat application running. I've created a Redis container. I've created 3 front ends, and I haven't built any infrastructure at all. All I've done is tell it to build a VPC, which there are plenty of CloudFormation out there for already. I've built a VPC, I've told it I want to define a cluster boundary, and then I've told it these are my containers, run this many copies. That's it. So there we go. Thank you, Liz. So yeah, we have a fully running service, no infrastructure built. That is the beauty of Fargate. I've included in the information here as well some bits and pieces to go and clear up your containers and delete the discovery service, so you won't keep accruing AWS costs. I'd say if you're going to do this, probably shrink down the size of the containers a little bit from the CloudFormation, drop the memory requirements down, and you can easily do this demo in the free tier and not incur any charges at all. So please do have a play. If you think of any bits you'd like to see added to this demo, please do. I've suggested some things you might want to do at the end. So Fargate supports a whole raft of things beyond what I've done. We can have flood at scale, yes, here we go. You can have auto-scaling in this. So we can monitor the application, and as more and more people join, we can take those 3 versions of my container and scale it a lot bigger. You can add that with a few simple changes to the CloudFormation script. So everybody have a go. Suggest changes. Submit merge requests back. Make me do more work next time I do this demo somewhere. Add things to it, please. I will really, really appreciate it. If you've got any feedback on that as well, drop it in there, and we can deal with that and work with it. Hopefully it's good feedback and not Rick, never come on stage again. So, I hope you've enjoyed this, and I'm quite happy to do some questions because I got through that quite quickly. So if anybody's got any questions and we've got a microphone about, that'd be awesome. Yeah, nice try trying to delete Redis. I did a very similar demo to this in Dublin, and I can't tell you half of the things that actually appeared on screen. It was like, I'll just change browser window now. But probably I won't understand most of this because it's going to be in French, which is, you can sort away. Yes, Dublin. So let's go back to this. And because I promised no slides, I had to think of a very inventive way of getting the URL up on screen for you all to copy. So that's actually my desktop wallpaper. So when I said no slides, I really meant no slides at all. My colleagues think this is a little bit of a cop-out and I'm trying to do half my job. But please go, pull it down, have a play with it. Let me know what you think. Let me know what else you'd like to see. If you want new features put in things like ECS and Fargate, let me know as well, and we'll work on that. Anybody with any questions? Oh, over here. This microphone just come in.
Is it possible to add more front-end container? Or?
Yeah, we can have a go if you want.
Yeah. Yes, please.
Let's try that. So if we go into our cluster and dive in a little bit, and we go to our service, which is Fargate Chat. I can say here update. I don't know why it says number of tasks 2 there. Maybe that's the default. Well, let's change that to 6. Next step. Update service. So let's go back to here. Refresh. I think that was right. So yeah, it's just a case of altering it there. It might not let me do it because it's in the CloudFormation, and I'm trying to override CloudFormation here. But we can have a go at updating the CloudFormation if you want, because when you're editing YAML live on stage, what can go wrong with that? Let's try it. So in CloudFormation here, I'm going to drop in and edit the chat service, and on here. Let's look for 3. Desired count. Let's change that to 6. Save that. Just make sure that didn't do anything. Oh no, it has worked. It's let me override it. So we've got one more task coming up. So we are adding front-end containers, and with any luck, we've not broken everything. Yeah, so it's pretty simple to do that. If you're actually going to do that, what I'd say is update your CloudFormation template and update the stack and do it that way, because then it's repeatable. However, if you're going to use autoscale, that's equally a good way to do it. It involves probably pulling some metric on this application that I don't have, because I don't really like doing autoscale purely based on CPU or memory. It's not a good metric to use, so number of concurrent connections would be a lot better for this. Any more questions? Liz has got one. Oh no, I'm going to take a drink of water before this, Liz, because
no, hopefully it's if you're using EKS, it doesn't show up in that same control plane. You know, you've got Fargate EC2.
That's correct, yeah. So EKS sits separate. It's only in Virginia at the moment, so it's not in the Dublin region. We are bringing out Fargate for EKS. So at the moment, EKS is a managed Kubernetes control plane. You bring the workers. It's much like ECS, but ECS being a different orchestrator. And we're going to bring Fargate mode out for EKS, hopefully by the end of the year. And that will just let you do the same things here. Use kube control, send us a container, send us the JSON or the YAML, and we'll spin the infrastructure up in the background. So, yeah, it'll be on a different part under the console, but same principle. It should work. Absolutely.
Hello. Is it possible to run stateful application inside Fargate?
Yes. You can still attach. You can still go there and you can attach EBS volumes within your YAML or JSON definition, and Fargate will place it in the right availability zones. So with EBS, if you've got an EBS volume and you've created it in EUS 1B, that disk lives in EUS 1B, not in 1A and 1C. So you need to start your container there in order to attach to it. But absolutely, yes. One at the front here.
Can we give to Fargate our own metrics to say how we can scale our container and our EC2 instance?
Yeah. So there's a couple of ways of doing it. ECS and Fargate, read into that, emit a ton of metrics. There's metrics coming out of everywhere. And you can use those metrics to trigger events. You can use them purely as a CloudWatch alarm and then trigger an autoscale event on that. You could consume them in a third-party service. You could have them trigger a Lambda function to do something. There are a lot of ways to do it, but yes, absolutely possible. There's also there's an open source project called Blocks, which is a way of building your own scheduler on top of ECS. So you can add more and more stuff on top of that. It wouldn't work in Fargate, but it would work in ACS. But yes.
Thanks.
Cool. Anyone else? Or we're all going to try and see what the football score is in a second, because it's just about finishing. Hope for a late goal. For France, of course. Thank you very much. Cheers.